Okay guys, today we're going to work on finding least common multiples. So that's section 1.4 in your textbook. And we're not going to do the entire section today. We're just going to do the first part of it that deals just with least common multiple. We're not going to get into the common denominator yet. So here we go. So again, let's figure out what it actually means in English. So least common multiple. Least means smallest. Common means both have it. And multiple is the number you can divide by both numbers evenly. So don't get it confused by a factor, which is a number you can that both numbers can be divided by. Okay, if you got confused on that, rewind it and just read it with me again. So the least common multiple is the smallest number that you can divide by both numbers that I give you evenly. So what does this actually look like? There is a couple different ways you can find the least common multiple. One of them is by using multiplication. So the first step would be to see if the smaller number can go evenly into the bigger number. And if yes, the bigger number is your least common multiple. Now, if it doesn't go in evenly, the smaller into the bigger, then start multiplying your bigger number by 2, then 3, then 4, and so on, until you get the number that can be divided by the smaller number evenly, and that will be your least common multiple. So let's look at the example. I think you'll understand it better that way. So for example, pretty simple, 6 and 4. I want the least common multiple. I want the smallest number that can be divided evenly by both of those numbers. So the first thing I'm going to check is, does my smaller number go into my bigger number evenly? So does 4 go into 6 evenly? It does not. So what I'm going to start doing is I'm going to start multiplying 6 by 2, then 3, and so on. So let's see. So first I'm going to multiply 6 by 2, and I'm going to get 12. And then I'm going to, and that's 12. That's 4 go into 12 evenly. So always check right away. I myself almost ended up doing more work than I had to. So does 4 go into 12? The answer is yes. 4 does go into 12 because 12 divided by 4 is 3. So that's even. Goes in evenly. So 12 is your least common multiple of 6 and 4. I can divide 12 by 6 and get 2, or I can divide 12 by 4 and get 3, and that's the smallest number I can do that with. So that's the one way you can do it. Now there is also another way to do this, and you might find this way easier or harder. I guess it depends on the exact problem and what you like. But the way to do it this way is to use prime factorization. So the first thing you need to do is find prime factorization of each number that I give you. Next, you need to write each prime factor, this is supposed to be factor, the greatest number of times it occurs in any of the numbers. So we're going to see exactly what that means, but if you have more factors in one number, more choose in one number than in the other number, you're going to use however many times it occurs in the one where there is more of them. Again, we're going to see in the example how it's going to work out. And the last thing you do is you multiply those factors that you just wrote down. So if you're confused, don't worry about it. We'll look at the example and it will probably make more sense that way. So again, 6 and the 4, we know the answer is going to be 12, but how can we get it by using prime factorization? So first I need to factor 6 and I need to factor 4. Pretty easy. 6 is 3 times 2, they're both prime, and 4 is 2 times 2, and they're both prime. Now, I need to figure out the greatest number of times that the factors occur and which number they occur in. So let's take a look at 3. 3 occurs once in 6 and 0 times in 4. So I'm going to use 3, the number of times that occurs in 6, which is once. So I'm going to write 1 3 times, and then I'm going to wait and see how many choose. 2 occurs once in 6 and it occurs twice in 4. So in which number does it occur more times? In 4. So I'm going to use it the number of times it occurs in 4, which is twice. So I'm going to multiply them by 2 2's. And then I'm going to multiply all of these by each other and see what I come up with. So 3 times 2 is 6, times 2 is 12. So 12 is my least common multiple. So now pause this for a moment, or you can go back and review the material and try to make sense of it and then try this. But in any case, try this by yourself and then push play again and see if you're going to get this right. Okay, so first let's try the multiplication method. So what I want to do is to see if my smaller number 12 will go into 16 evenly. The answer is it does not. So I need to start multiplying my bigger number 16 by 2, 3, and so on. So 16 times 2, 6 times 2 will give us 12. 1 times 2, 2 plus 1 is 3. So that's 32. Can 12 go into 32? No, it cannot. So next, I'm going to try and multiply 16 by 3. 3 times 6 is 18. 1 times 3 is 3 plus 1 is 4. So 48. Can 12 go into 48? Yes, it can. Think about your days and hours. 4 12-hour periods will give you 48 hours. So 12 does go into 48, so 48 is my least common multiple. Another way I can do it is I can use prime factorization. So I can factor 12 and I can factor 16. So they're both even, so I'm going to start easy. I'm going to divide them by 2. I know 2 is prime. And 6 times 2 gives me 12. Then I can break up 6 a little bit more. I know that it's 2 times 3. These are both prime. And then 16, I know I can divide that by 2, and I can get 8. And then again by 2, and I can get 4, and then again by 2, and I will get 2. Now I need to write down the factors of the factors of these numbers as many times as they occur in the number where they occur the most. So let's take a look at the 2's first. 2 occurs 2 times in 12. See that? There's 2 2's there. It occurs 1, 2, 3, 4 times in 16. So are you going to use it 2 times or 4 times? Well, it occurs in 16 4 times, which is more than 2 times in 12, so I'm going to use it 4 times. So 2 times 2 times 2 times 2. Then I'm going to look at 3. 3 occurs in 12 once, and it occurs in 16 0 times. So it occurs in 12 more because 1 is bigger than 0. So I'm going to write it down once, and then I'm going to solve this. So 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. And 16 times 3, we just did it up here, is 48. And you can see how we got the same answer that way. So it's up to you to figure out which way you like better. Either way is perfectly fine by me as long as you get the right answer. Okay, so feel free to watch this over again. Oh, I almost forgot. We can also use the prime factorization to find LCM of algebraic terms. Now, algebraic terms are things that have numbers and letters stuck together, just like this. So, seeing if the smaller one can go into the bigger one at this point would not be a very good method for us because, quite frankly, it would be impossible. So I'm going to use prime factorization. So I'm going to break this up, and I'm going to see, 35 is what times what times what? 35x squared. And 175xy is what times what times what? So 35, I know, is 7 times 5. Both of those are prime. So 35 is 7 times 5, and then x squared means x times x. So I'm going to write it right here so you know what I'm talking about. X squared is x times x. So I'm going to write it, my 7 went away. I'm going to write times x and times x. So this is my prime factorization of 35x squared. There's my 35, there's my x squared. Then I'm going to break up 175. I'm going to take it to the side here. So 175 ends with a 5. So I know for sure that I can divide it by 5. And when I divide it by 5, I end up with 35. I can divide 35 by 5 also, and I will end up with 7, which is also a prime number. And then I can write down the factors of 175. So it's 5 times 5 times 7. And then don't forget your letters. It's also times x, because if there is nothing between a number and a letter, that means it's multiplication. And also times y, because again, there is nothing between, that means it's multiplication. Now I have to see how many times each factor is used in each number, and the number that it's used in the most is the ones that I'm going to use. So let's see. 7 occurs once in 35, and it also occurs once in 175. So they're even, so I'm going to use 7 ones. Now, 5 occurs once in 35, and it occurs twice in 175. It occurs more times in 175, so I'm going to use it twice. Then I'm going to look at my x's. The x occurs twice in 35x squared, and once in 175xy. So I'm going to use x twice. And then y occurs once in 175xy and 0 times in 35x squared. So I'm going to use y once. And I'm just going to multiply all of this out. So 7 times 5 times 5, well, we can just look back here. 7 times 5 times 5 is 175. And then x times x is x squared times y is just y. So I'm going to just glue them together like this. Remember, there is nothing in between. That means it's multiplication. And that's it for this one. I'd like you to try this one on your own very quick, and then push play and see if you got it right. Okay, so I'm going to go through this pretty quickly because I'm running out of time. So here we go. 16, I can do 2 and 8, 2 and 4, 2 and 2. And then a squared is just a times a. 56, I can do 2 and 28, 2 and 14, 2 and 7. And a squared is a times b, because there's a b there. So I have 4 2's over here and 3 2's over here, so I'm going to use 2 4 times. And then I have a 1 7 here, no 7's here, so I'm going to use 7 ones. I have 2 a's here and 2 a's here, which is even, so I'm going to use it twice. And then I have 1 b here, no b's here, so I'm going to use b once. So then 2 times 2 times 2 times 2, we know is 16. Then 16 times 7 is going to be 112. So 112, and then a times a is a squared, and then times b, and so 112 a squared b